Alright, in this video we'll be looking through Pythagoras, what it is, where it works, and why it works. So it works on a right-angled triangle, which we'll label like that. We'll drop these labels very soon, but for now it's helpful to think of A and B as the smaller sides and C as that long diagonal red one there. And we're going to wrap all of this up inside a big square with the labels gone now. And we've made the square in such a way that if I get 4 copies of the triangle, I can arrange them around the square in this way. And all I'm going to do now is keep track of how much empty space is still inside the big square. Okay, and so right now, the empty space is just one big red square, which if we were keeping track, is c squared. So we'll keep that for now. And now all we're going to do is we're going to reshuffle where those triangles go. So I'm going to move that one down and that one down, shove those ones up, and I hope you can agree that the amount of empty space should not have changed. Because all we've done is reshuffle those triangular pieces. We haven't stretched anything or added anything or removed anything, so the amount of empty space should still be the same. But now the empty space is made up of 2 bits, 2 squares. One of them's a square, the other one's b square. And so what that means is that a square and b square put together, added together, must be the same then as c squared. Okay? Now all of this, I think, happened on a right-angled triangle to begin with, and when I go to use this, I normally don't think about the equation or the formula. The important thing to keep track of is which side is the longest side, which right now is the C. But how could you know for sure? How could you make sure you got that one right first? It's always the one opposite the right angle, and we call that the hypotenuse. Okay, but once you've found which one's the longest side, all you need to think about, and all I think about when I use this, is the fact that the 2 small squares add up to the big square. Okay, so once you've worked out which one's the biggest, all you got to know is the 2 small squares add up to the big square, and that's, I think, the easiest way to work with this. So let's see a couple of examples. First one looks a bit like that. With this one, again, the most important thing to work out is which one's the longest side, so we shoot across from the right angle, and we see that x is the longest side. Okay, so now we can work our way there. The 2 square is 4. The 3 square is 9. The longest one, the x squared, is the one that we don't know. But what we do know is that the 2 small squares will add up to the big square, and so we get 4 plus 9 being 13 there. Okay. Now that's the x squared, right? So how do you get back to what x is if you know that x squared is 13? You can undo the square by taking the square root of 13. And so that's going to be your answer for that one. If we tell you to round it, you can put that in your calculator and round it. If we don't tell you to round it, you can just leave it as root 13. That is fine. Okay. Here's another one. Looks a bit like that. So once again, the first thing to do is to locate your hypotenuse, which side is the longest. So you shoot across from the right angle. This time you see 13 is the longest side. Now we work out the squares. Well, 12 square is 144. Y square, well, I don't know that one. I got to work out that one. But I do know that the longest one, the 13 square, is 169. So while I don't know what y square is, what I do know is when I add the 2 small blue squares together, the answer has to be 169. And so that means that what's in that blank blue box, the y square, must be the difference between 169 and 144, which is 25. Okay, so y square must be 169 minus 144, which is 25. And again, to get back to what y is, we can take the square root of 25, which gives us 5 this time. Okay, so sometimes the square root will work out nicely, sometimes it won't, like the x one. If it doesn't, then you can round if we ask you to, or just leave it as a square root if we don't ask you to. Okay. Last example we'll see is to use this to work out maybe a harder perimeter question. So let's draw it out. First, it looks a bit like this. All right, and this shape is made of two pieces. Okay, the two pieces are, you've got this yellow arc here, which is really 3/4 of a circle. And the other piece is the straight bit, which is the hypotenuse of, well, it's a right angled triangle. Okay, now we don't count the insides of the triangle because they aren't part of the boundary, the outside of the shape. So if we care about perimeter, we just need to add up the yellow bit with the green bit. Okay, so let's start with the yellow bit, that one there. Okay, now we know it's 3/4 of a circle, so let's write that out, that the length must be 3/4 of something. It's of a circle, right? But what's the length around a whole circle, around the whole circumference? Well, previously we said that that was 2 pi multiplied by the radius, so 2 pi r. But here we know that the radius is 3, so that means r is actually 3, and I might just leave that as is for now. Okay, I'm not going to put that in my calculator yet because I know I've got to work out the green bit as well. Right, and so I don't want to encounter rounding errors early, so I might just leave that as is for now and move across to the green bit. Okay, now for the green bit, well, we know that we're trying to work out the hypotenuse, so let's go straight to the squares this time. 3 square is 9, and the same square happens on the other side because the vertical one's also 3, it's a circle, so they're all the same. And so the big square must be 9 plus 9, which gives us 18 for that one. So that means the green length must be the square root of 18. Okay, and so now that I've got those two pieces, I would enter all of that into my calculator in one go to work out the perimeter, right, to be those two things put together, which then gives me 18.38. Okay, and so I would leave the calculator step to the very end to make sure that I'm rounding my final answer, and that way it's as accurate as I can be. Okay, and so that's how you get the perimeter of a shape like that. Thanks for watching. See you later.